In this video, I will demonstrate how you can use online parameter estimation to detect changes to your system as they occur using an internal combustion engine model. There are three parts to this model: the nonlinear simulation built with base Simulink blocks, a recursive estimator that utilizes the recursive least squares estimator block, and the estimated model which I can use to validate my estimation. Let's start by running the simulation and observing the results of the nonlinear model. As can be seen in the scope, the RPM pulses between about 4,000 and 15,000 RPM based on the throttle input. At 100 seconds, we introduce a drag torque on the engine, causing the dynamics to change. Let's move to the recursive estimator portion of this model to see how we can detect this change with online parameter estimation. We create the estimation by first building up the regressors for the recursive estimation. These regressors are the terms used to estimate the model output. Here we see that we require 5 parameters to accurately model the system. The number of parameters used here will be reflected in the recursive estimator block from the system identification toolbox. We will also output the error and covariance matrix to verify our results. After running the simulation at a nominal operating condition, we see that the first parameter is large relative to the other values, and thus we have the least confidence in this parameter. The other parameters have a low covariance value, indicating higher estimation confidence. We will use these as a snapshot of the system before the disturbance and verify the estimation in the estimated model section. Using the same regressor model as above, the output is now multiplied by the estimated parameters we captured previously. The second input to the regressor block is now the estimated output. Running the simulation, we can compare the output of the estimated RPM to the actual RPM and see there is a good match until the torque disturbance is introduced. Now that the estimated model is verified, we can confidently use the A1 parameter from the previous model to detect the inertia change. Once we determine how we want to use this information in our control system, we can then generate code for the estimator and deploy it to our embedded system.